So this is worksheet 3, number 8. The number of bacteria in a culture is increasing at a rate, so that sounds like dB dt. If we're going bacteria, you want to go P for population, that's fine. Proportional to, so K times, and then the number of bacteria, well, that was what our B is. There are 125 bacteria in the culture after 2 hours and 350 after 4 hours. Why is this kind of bad news in terms of the information it gives me? It doesn't give me anything with 0. So that's kind of unfortunate. It means my life's going to be a little harder for figuring this out. We really like it when they give us a 0 because that wipes things out. Didn't do it here. So it doesn't affect the calculus, but it does affect the algebra. So yuck on the algebra when we get there. dB over B equals K dt. Okay, this is what we were just working on. Power rule or natural log? Natural log. Again, if you aren't sure, then you start out trying power rule. And you say, well, b to the -1, if I increase the power, I get b to the 0. And then I divide by 0, and then realize, wait a minute, that doesn't even work. Because it's natural log. So, natural log of b equals kt plus c. Frequently, I get a little lazy with the absolute value bars. It's supposed to be there when you write it down first. But in the context of this problem, B is the number of bacteria. That's never going to be negative, so I don't really have to worry about the absolute value bars. And so if you left them off, you'd be fine. Most of the time, if you ignore the absolute value bars, you're going to be fine. But you better be careful, because if we throw something in there with a negative, then it would matter. Okay, this is our algebra e to both sides, or do the fishhook thing. E to the kt plus c equals b. And then maybe for the last time I'll write this extra step in there. The extra step that nobody shows because I don't really like it. But it's what allows us to sort of rewrite this as c e to the kt. Okay, I think my calculus work is over. Now it's algebra time to plug in my conditions and see what we get. 125 equals c e to the 2k. Oh, this is what we didn't like because there's still 2 variables in there. Or, well, they're not variables, they're constants. There's 2 unknowns in there, so I can't solve for one of them. Let's plug in the other one and see if this helps at all. So 350 equals c e to the 4k. Well, that doesn't really help either. Alright, algebra super all-stars. Any idea what we could do? Because I got 2 equations and 2 unknowns, so like algebraically speaking, I ought to be able to solve this, but we haven't done one like this. What I think I want to do, the easiest thing to do, would be to divide one equation by the other. And probably the big one by the little one, because that will just make life a little easier. So I'm going to divide by 125 and divide by c e to the 2k. Oh man, those are not good faces.
I don't like this.
But the reason I'm going to do that is what happens over here? The c's cancel. And what's e to the 4k divided by e to the 2k? E to the 2k. And 30, I guess I'll just leave that as 350 over 125. I'll have a calculator, so. Okay, so now I'm on the road to finding k. But yes, there was a crazy step where I divided one equation by another to make the c's go away. And that all started with, you recognized it early on that they didn't give you a 0, which meant this was going to be a pain. And that's the pain that not giving you a 0 caused. So let's natural log both sides. So k equals, this is going to be a calculator thing, and I will leave it in the calculator. Natural log 350 divided by 125, all divided by 2. I could write that down, but why even bother, because I'm just going to store it as k. Oops. Now, I don't really need to say that I'm storing it as k, because I've said k equals, so that means it's in there for k. Okay, now I need to go back and figure out what c is. And I've got two choices. It doesn't matter. Either one will tell me the same c if I did this right. So probably the smaller one would be easier to work with. So 125 equals c e to the 2k. But k isn't unknown anymore. K is whatever, 0.51, but it's in my calculator. I know what it is. So that means I can figure out what c is. 125 divided by e to the 2k. .643, and since that's a weird number, I may as well store that as c. So now I've got my formula, and I can write it like that because now I know what c and k are. So that's my, so that's not my final answer because that's not what it asked. Find the initial population. So that would be if t is 0, c e to the k times 0. Oh, so c is my initial population. 44.643 bacteria. More so than most. That's deserving of the calculus is easy, algebra is hard. Because the only calculus step in that problem was right there. Right? Everything after that was algebra. Plug it in, and then 2 equations and 2 unknowns, and then plug in some more stuff. Yeah. So I'm glad you asked number 8. First, because it was a natural log problem that's different than the first one we looked at, and then second, because all the algebra was a mess. So that was a good one to look at.